Good afternoon to all of you. I think I'm very fortunate, as much as you are, as very young people who are walking out into the street after your graduation. There are three things that your bosses are looking at you. One, are you productive? Two, are you cost effective? True. And the third thing is, are you producing something that is required for the customer or whoever you need? Now, if you need to meet these three things, then you are productive. Then your degree is worth what you get. If you don't have those three qualities in you, then it doesn't make you where you are. So with that, I want to start with what it takes you, how to be productive. And in this particular area, I am referring to machining, which is what the mechanical engineering student should benefit out. In an unconventional way of thinking, any one engineer will be looking at a machining center from a conventional way of how the designer designs and works. But if you are out there as a young engineer, you've got to look at yourself differently. And I gave this word in many cases, and I'm giving it to you again. You have to adopt this acronym that I'm going to give you. And that is, you eat what you're doing, you shit on it and you sleep on it, and then you're productive. If you don't have that, then you're not going to be productive. You don't have the mind to think about it. And that brings you to be innovative. Now let me take the first slide. Next please. Can I have the next slide? You're eating into my time. It's not working. Okay. Any young engineer would have seen these. And these are anvils, which are used for cutting metal. If one looks at this metal and he thinks of the way the designer designed, he will only think of the next slide that I have. And that is this way of doing it. A conventional way of milling, removing material from another piece using these anvils. Now that's not good enough. Now the designer works something more, and they came up with different types of anvils. And they came up with this kind of anvil to give you different shapes. In the first instance, he had a square anvil. In the second instance, he had a T-slot. But in order to do a T-slot, you need two tools. First you got to cut the blade, then you have to cut the slot. And in that case, where you have to have a semicircular, you have a single tool. And the last one, you can see, is just a little bridge. Now, in modern day machining, which is CNC, we have this tool called the arbor, where your anvil is fitted and a program is done, and you machine out the parts. What happens? Each time a tool is changed, the arbor moves and the next tool comes on board. Yes, you can say it's programmed, but that's not good enough. You've got to think differently. Can you think that a single tool can do two functions for you? If it can, then you are in business. Because the moment you reduce a single minute in a single operation, and if you are producing 40,000 pieces per hour, can you imagine the time that you save? And that's a marvelous thing. Just a single minute for 40,000 pieces in a single hour. Now, I'll have this slide. And this is for a video for you to see how conventional milling takes place, and then I will give you what it takes you to be innovative. Please, turn on the video, please.
look at those in machining, what you saw is just machining on the surface. But if you look at the capability of the machine, there is one more activity which is called plunging. In a milling machine, you can plunge. So you got to take the idea in, and you just look at the three items that I said. Now, to do a counter ball for just a simple ball, if you are doing CNC, a conventional person thinks of two tools. First, a drill through or an helmet to plunge in right through, and then the next with a different diameter to adapt or to accommodate. But what you can do is to reduce that one tool. You take a single end mill, you reshape it with a grinding wheel to the required and plunge it through directly. And if you do that, you don't need to have two tools but a single tool. And that's what you can do. An end mill can be shaped this way. Now with this process, you have saved a single tool change time. Just a single tool change time. This is a very simple process I'm going to tell you. Now the next slide I'm going to do is for a single. If there is a block and you have to put an O-ring inside, conventionally you have three tools to do this. But I feel you can do it with a single tool, which means you save two tool change time. And if you save two tool change time in a single operation, you are saving 2 minutes for operation. And here, what you can do is this. Now, this is how you shape the tool. You shape the tool in such a way that the end mill has a single center line. You've got to create a second center line. And therefore, you need to offset the end mill. You grind it in such a way that you can plunge it. But the end mill and the CNC machine has a capability which I'm going to dance and show it to you now. An end mill moves this way. But what you do is, when I move it on this way, this is my axis. But if I cut this portion off and I shift my thing here, and now I cut this way, I have another circle. But the CNC machine has a capability of not only moving in this single axis, but now it can move in a circular direction. With a different axis, it moves this way. And it comes back to the center, back to its original center. And by doing that, I have created an O-ring cavity for you to place the O-ring. Now, that's what you need for. Now, in order to do this, you have to be very smart by thinking of the three keywords that I told you. One, eat on it, shit on it, sleep on it. Don't give me too many clapping hands. Let me say this. The qualities that an engineer or any person in any business, when you walk out as a young graduate, you have to have these qualities in you. Anything and everything you do, try to be different from the others. You got to create differentiation. And what do you do by creating differentiation? You dress yourself differently. You comb your hair differently. That's what the young people are thinking about. But when you get to a working situation, your boss is not looking at you how you dress. It's not how you wear your shirt, but how you give in the output. And how you reduce the cost of the product. Or how you market the product into the world. And therefore, you've got to be very focused. So the second quality is, first, you've got to be different. You create differentiation in the product that you are working on. Second, you've got to be very focused. And the focus here is, you've got to be very focused on the cost, and you've got to be very focused in terms of time. Because that's the hour that you're paid for. You get into work at 7 o'clock and you finish it at 4 o'clock. And that's the hour you're paid for. So if you can utilize your hours very well, producing the parts that you need to, you are competitive. Now the last element is, if you want to be innovative, if you want to be creative, you've got to turn on your radar. And what do I mean by your radar? In the case of an aeroplane, radar is right in front of the aeroplane. So all of us have a radar here. So when you walk into your production floor, or your working environment, turn on your radar. Smell what's happening. Smell what the market needs. Listen to what people have to say. What are they looking out for a product in terms of cost? You got to make clear observations, for which I admire the Japanese. They came with cameras at every single plant, and each time they came in, they will tell you, Daram-san, can I take a photograph, man? I said, no camera, please. No, small one only. That's what the Japanese man says. Why did he say that? Because he doesn't have a photographic mind, but he takes a photograph of a design which he can apply elsewhere. So that's your radar. So when you walk out, please make observation and try to synthesize that observation in your working product, and you will be successful. Now that's all I have for you. So the examples I gave you is just a countersunk and countable and an O-ring ring, but there are many more you can do. Believe me, I'm standing in front of you, not just producing these, I have produced more than these, and there are many more ideas. Thank you. Now I'll open for questions.